Hello everyone, my name is Kim. Welcome back to another question. Today we're gonna work on another fixed size problem. So the question right now is asking, given an array of integer and two integer k and the threshold, return the number of subarray k and the average is greater than or equal to threshold. So we look at the array and the threshold is 4, the k is 3. So basically the subarrays need to have a size of 3 and the threshold is so that the average is greater than or equal to the threshold. Initialize of 4. What is the output? Output of 3. So let's say we need to sum these 3 together, which is 6. Divide by 3 is 2. Is it less than threshold? Smaller than, so we don't count it. So no. And then to the next one is pretty much the same. 6 over 3 equal to 2, and then 4. No. And then we're gonna move to the next. 2 to 5. So 2 to 5 means 9. Divide by 3, we have 3. Less than 4. No as well. Then we move to the next. 2, 5, 5. So 12 minus 3, which is 4, equal to 4, the threshold. So this is 1 yes. Okay, next one. 15, 5 plus 5 plus 5, 15 plus 3 to 5, greater than 4. So we have the second one. Lastly, 5, 5, 8, obviously 18 times 3. 6 something greater than 4, so we have 3, which means the output right now is 3. So look at the example that we have. Yes, it's correct. How do we gonna solve this problem? So if you can see all of these methods right here, because we divide by k, so instead of divide by 3, we just multiply the k to the threshold. So k multiply threshold. And then we compare with the sum. So see who is the king of this problem. What I will do is instead of adding 3 numbers, so I'm gonna iterate everything from k minus 1. So that I can add in or add the numbers or subtract the numbers basically. So I got the sum will be 2 plus 2 equal to 4, and I iterate I. So for index equal to 0. So I add these two, meaning I got this total of 4. And then I add the 2's right here. So if it is greater than 6 in totals, so if it's greater than the threshold, what is k? And the threshold is k3 threshold is 4, so 12. Because this is smaller than this, let me say it the start here. Because it's like smaller than start, meaning we don't use it. Move the next point, we're gonna do the same. So if it's less than the threshold, we're gonna move our pointer. So we're gonna remove the first one. And now move our pointer to the next. Doing the same thing, if it is smaller, then we move to the next. Okay. 2 plus 5. So this is 9. It's still less than, so we're gonna move again. Until we see 15. And 15 is greater than start, which is 12. If it is greater than 12, we can increment the count. Doing that the same and the same again, so we're gonna have our solution. So let's move to the code base. I want to make sure like you understand the logic behind before moving to the code. I'm gonna have a count equal to 0 and the current sum. So I'm gonna sum all of the numbers from array just k minus 1 so that we can increment the first sum. Just gonna do a left pointer, inch range, length, k minus 1 plus 1. We're gonna add the element next to it, current sum, left plus k minus 1, and then if the current sum greater than equal to the threshold plus time the k, and then we're gonna increment our count. Otherwise, when we iterate to the next index, we have to remove the sum from the previous one. Okay, now we're gonna return the count. So we need to iterate every single element in the array. The time complexities would be O of n, and the space complexity is O of 1. Awesome. Thank you guys. We'll see you in the next class.